Hello and welcome to Golden Geography. Today we're going to be looking at some geographical skills, and most specifically we're going to be talking about different types of graphs. We're going to think about the data you can present in these graphs and, more importantly, their strengths and weaknesses in showing data, which is important for the OCR exam board A-level geography questions, which do often look at the strengths and weaknesses or advantages and limitations of data presentation. We're going to start with really simple graphs. These are the ones that you've probably seen in textbooks or may have even produced yourself in the past. They are very basic, like bar graphs or line graphs or pie charts, and are very easy to read on the whole, but they have their own individual strengths and weaknesses. So we're going to start with line graphs. The point of a line graph is to show changes over time. This tends to be gradual changes that are experienced by the particular piece of information you're recording. For example, temperature, gradual changes in temperature, really well shown on a line graph because it shows those gradual changes rather than having non-continuous data that's much more better presented in blocks on a bar graph, for example. So line graphs show gradual changes. We've got a few examples here. Very good for showing trends. It's easy to pick up trends. It's easy to see what the data is showing you. And you can actually read the exact values of them. However, their disadvantages or limitations is it's a line you might have 2 or 3. They're not particularly visually appealing. And they're limited really to data sets of under about 50. Once you get beyond 50, it loses some of its clarity and some of the numbers and the data can get lost a little bit. You can have an unrealistic interpretation of data that's between points because it's often a smoothed curve that we have there. And any anomalies can really distract the trends that you're seeing there. They can really distort those trends. Bar graphs, simple, straightforward bars, very good at showing kind of grouped data. So here, rainfall that happened potentially within a day, or it could be a month, but data that's grouped together. Very easy to construct, good comparisons. It's fairly visually strong, particularly if you have different colours for your different categories. Again, you can have the raw data there. It's easy to read off those numbers. Disadvantages, it doesn't show gradual changes. Those blocks have to be separate. You're looking at using something called discrete data, really, data that is definitive within that particular set that you're looking at. It doesn't really show any complexity within the detail of the data itself. Pie charts, lovely. They are proportional though. They're very good in terms of their visual elements. They're great for showing you different proportions. They're very visually appealing, but they do need to be labelled. Ideally, they will have percentages with them, so therefore they don't necessarily show the raw data or the original data. It's hard if you're trying to use it to compare 2 sets of data. You'd potentially need 2 pie graphs for that. So although visually impressive, actually there are some limitations with the way that that information might be interpreted. And if you have particularly small segments as well, that's very difficult to pick up on. They may be too small to see. Scatter graphs, plots here, you're looking at 2 key values that you're trying to see how they correlate with each other. It's very easy to plot. It tends to be clear. It's good and easy to see correlations or lines of best fits are easy to put on here. But again, anomalies can be a distraction. They can kind of distort a little bit the main patterns that you are looking for. And depending on the data, you might have so much that you might find it difficult to see those patterns, particularly if the correlation isn't really that clear. The relationship between the data isn't that clear. So good, but some clear problems there. Pictograms, lovely, pretty, visually appealing, easy to read, but If you've got a value that's partial, then it's hard to show that. So you've got 3.5 cupcakes for Thursday, 2.5 for Tuesday. Is it a half? Is it a quarter? So, you know, although it's pretty, it's limited. It's best with whole values, and it's best if you stick to just a couple of categories. It is a very simplistic way of showing something. With all of those graphs, if you are asked questions about them, do always think about the source. So where is that data coming from? What is the date range of that data? How relevant is it? So is it only showing you one particular area, or is it showing you a country or the whole world? Think a little bit critically about the data that's being represented in those graphs. Okay, complex graphs are exactly what they say on the tin. They are a lot more complex, and they tend to be designed for very specific types of data. There is a little bit of flexibility within that, but they do show information in a much more detailed way, and sometimes they're even geolocated. So we'll start with population pyramids. These are designed to show the difference between age and gender. You always have males on the left, females on the right, and divided up into age categories. They are visually impressive, and if you have several, they are good to see changes over time, particularly if you're looking at one particular country and you can see the changes over a 100-year period within their population. Biggest problem we have now is that we here only have 2 genders. It doesn't represent all the different genders that are now recorded on the census. Age categories are often bracketed, and those age brackets can vary between different types of population pyramids. And it literally is just a snapshot in time. It only shows you the population for that particular place at that particular time. People are born and die every day, so it doesn't represent those changes, but it does represent that place at a particular point in time. If you're looking at a cross-section, very often they look like a line graph, so they have some of the advantages and disadvantages of those, but they're often used to represent topography. So the top here we have a beach profile, and again it's just gentle, it's just showing you the changes across the beach in terms of its cross profile, and at the bottom we have one which has 4 different cross sections. Cross sections tend to be for beach profiles, but you can have it for areas of high relief, so mountainous areas. You can have it for glacial readings as well, showing you changes in ice level and ice depth. They're good, they're clear, they're very good for comparing multiple locations, but if you do compare them like the bottom one does and they overlap, it can become a little bit tricky. So GIS is Geographical Information Systems, and that uses geolocated data, so data collected from a very specific locational point. It has a latitude and a longitude associated with it, and GIS very much overlays that data. So the top image is GIS, bottom image is more geolocated, where you're pinning data or a photo to a specific point. GIS is where you've got that data and it's put into, in this case, a topographical map, but it could easily just be bar graphs as well on a map. Advantages are these are great visually. That's one of the key things. They're great. They can be updated regularly. And if you think about the maps that we use in our sat-navs or TomToms that we use to guide ourselves around, they are often updated with traffic jams or delays here. That's how we can put this technology into good use. Some of the disadvantages are that, particularly with GIS, if you have areas that are very similar values, they might be blocked together and you might miss any anomalies or slight changes between them. Variations can often be quite difficult to see. It really only shows one key category. Once you start getting multiple different categories, depending on the type of GIS that you're using, it can get quite complex to see individual bits of data. We do have divided, sometimes called proportional bar graphs as well. Great for showing variations. It's good for comparing, as we have in this example, populations over time. but it is best done using proportions or percentages. Therefore, you lose that raw data. You don't really have the values that represent the numbers of data that you've collected. So you do have to look at it in terms of being it proportional, and that can be a little bit challenging sometimes. Here we have a proportional map. It's overlaid data for coronaviruses in Europe, but it's done it proportionally. So the map itself is very visual. It's good to compare places. Disadvantages are the proportionality, the circles, the different size. The bigger they are, the bigger the cases of coronavirus in this example. So where we have big numbers of France, Germany, Spain, Italy, sometimes they can obstruct any smaller values beneath them where you can't see them because the big circle is hiding the small circle beneath it. So that's the key issue here. And also the scale, you're jumping up exponentially and you've got big changes here. So yes, it's great for showing something on a much more larger scale, regional or global scale, but some challenges with proportionality. Similarly, you can have proportional flow lines that you put on a map. Again, very visual. It's good to show things like migration or trade or export of goods between different parts of the world or movement of people. But apart from that visual impact that it has, it can be hard to produce. The larger arrows in this case can obstruct smaller ones beneath it. And the scale can be difficult to see again and to work out. These are a bit of a favourite of mine, but they are a bit tricky. Triangular graphs. This is when you're looking at plotting three different sets of data, ideally, and you're looking to see where those three bits of data come together. It's good because it's very visual. You can always check it that it adds up to 100% because that's the concept here. And it's good for comparisons, be able to look at different sites or different bits of data to see how they vary or compare, but it can be very hard to produce, and sometimes they don't always have the guidelines on them, so that can make them hard to read, particularly the values or the percentages of them. So in this case, it might be hard to read the other services, the gentrification and the immigration values. So great graphs, but always sometimes a little bit tricky. We have our choropleth maps, very visual, easy to interpret. Difficult sometimes to see the variations in the shades. So if you have lots of different shades of one colour, like we do here, sometimes the lighter colours are very close together, so it might be harder to distinguish those. It's often got data that's grouped together, so any anomalies within that. So if we look at Florida, there might be an anomaly within the state of Florida. It's not shown because it's going for the average or the overall. It doesn't show any gradual changes either. Isopleth maps. These are fantastic. You're probably most aware of these in terms of contour lines on a map showing the height of a map, but they are also really good for showing things like temperature, it could be wind speed. Basically everywhere on that particular part of the line is the same value. It's great because individual data can be left on it as well as showing the grouped data, the line itself. But the disadvantages, you need a lot of data for these. You need to make sure you've got potentially at least 100 bits of data, and they can be hard to construct, particularly if you have lots of variation within them. Okay, so that's a bit of an overview. Do be aware, as I said earlier, about the sources of the data, where that data is coming from, what's it representing, is there any locational data missing? So would it be better if it had some latitude and longitude marked on it, or if it had some place names marked on it, particularly if you're looking at maps? So do think about those kind of limitations as well as the ones specific to the graphs themselves. So, quick little look here at some OCR past exam questions. This one is from the physical paper in 2018. It's a choropleth map looking and showing precipitation across mainland USA. And you can see here the question 4A2 is asking for limitations. Feel free to pause this video and have a go at answering these two questions. Here's a paper from the 2018 Human Geography paper, and here we have a bar graph. And again, we've got questions based on that, and the question 2A2 it's asking for variations, reasons why we might have the variations that are shown. So you need to be able to interpret these graphs. Again, feel free to pause the video and have a go at those questions. This is from the debates paper. It's got here a proportional map for us. So what they've done is areas of low values are really skinny, like the Americas. Areas of high values, like Africa, is being blown up. It's being enlarged. So it's very proportional, the map that we have here. Again, feel free to pause the video and have a go at interpreting the map and answering the questions. And here's another graph, very basic scatter graph here from the debates paper in 2018 that you can have a little look at here. Okay, well done. Do bear in mind we've got lots of different types of graphs. You don't know which ones will come up on the exam papers. They could be on any of the exam papers, and you need to be able to interpret them. You will also need to be able to use and produce your own graphs as part of your NEA independent investigation. So you need to be able to look at data and go, what would be the best way to show this data? What's mostly appropriate for this data? And how can I do that? How can I present it? Thanks for listening.